Good afternoon, everyone. My name is Sumit, and I am a senior application engineer at Ideas Design Solution. Today, in this presentation, I will be talking about SolidWorks Tool Analyst. So, without wasting further time, let's start with the presentation. So, before starting the presentation, let me just take you through the overview slide, what we are going to cover in this session. So we'll talk about tolerance take-up analysis. What is this toll analyst tool that we are talking about? Why do we need a toll analyst tool? What benefits do this toll analyst tool offer? And finally, we will see toll analyst workflow within this presentation. And at the end, we will see a live demo in SolidWorks assembly. So basically, tolerance take-up analysis is a study of dimensions and tolerance schemes to determine if an assembly of a part will fit together and function properly. So for example, here I have a four-part assembly, and in this four-part assembly, I have a gap. So I want to calculate this gap. So there are various tolerances schemes are attached to each dimension. So how do I calculate this? For calculating this, we can use our manual methods, or we can use a tolerance analysis software which is integrated in SolidWorks. So when to use tolerance take-up analysis, so if you have parts that are interfering with each other, and if you want to see what are the actual max min clearances, what is the maximum length of an assembly, and if you are interested in seeing what is the maximum distance between shafts and holes, then you can do a tolerance take-up analysis. So there are two type of tolerance take-up analysis that we can do in SolidWorks Premium. So the first one is worst case analysis, and the second one is statistical RSS, root sum square method. So in worst case analysis, here is an example of a four-part assembly, and there are tolerances attached to each dimension. So what I will do is, I want to calculate the minimum gap between the part number 4 and part number 1. So for doing that, what I will do, I'll take my complete length of the cavity, then I'll just minus the maximum value of these three parts. Alright, so taking a worst case scenario, I'll take the minimum value of this cavity, and I will just subtract the maximum value of these three parts from that value. So here I've seen that there is a 0.5 value is coming, and it is in minus convention, so which means there is a interference is going to happen. After that, there is a RSS, that is root sum of squares analysis. In this method, what we do is, I want to calculate the minimum gap in this one as well, or maximum gap in this. So what I will do is, I'll calculate the nominal gap between these two parts, part number 4 and 1, and I'll just add or subtract the root sum squares of the tolerances. Alright, so here is my nominal gap, that is 2, and here are sum of tolerances, which is including this tolerance 0.25, 0.5, then 0.75. So these are the tolerance, and after that I'm getting a gap minimum of 0.631 and the maximum value of 3.369. Now we are talking about what is toll analyst tool, that is in SolidWorks Premium. So the toll analyst tool lets you perform max and minimum tolerance take-up analysis on parts and assemblies. Also, you can do a RSS min-max calculation in software itself. So basically, you get three analysis results from the software: the worst case max min value, the RSS max min values, and the contributor list by percentage. So what a contributor list is, Here is an example of contributor list dimensions. So here is a dimension 1, and these are the each dimensions that are referring to that particular phase. So this particular dimension or this particular phase is contributing 18.46% to the final my study. So what I can do is I can just double click on my tolerance and just change that tolerance so that I can get max min value within my range. Also, you can export this result to Excel so that you can prepare some documentation for that part as well. Why do we need a toll analyst option in SolidWorks? So to perform if you are performing manual tolerance stack-up analysis, that takes so much time. All right, so if you are designing some high precision components, you might need toll analyst. If you are designing products that are going to be produced in high volume, then also you will need tolerance analysis. And anyone who is currently suffering from assembly fit problems will be requiring this toll analysis study tool. What benefits do this toll analysis tool offer? So using the toll analysis tool, you can reduce the prototype for testing assembly fits. You can optimize the tolerance schemes for your assembly and manufacturing. It is a fast evaluation method for tolerance stack-ups, and you can see the graphical display results within the SolidWorks window itself. Also, you will be able to know that what is the worst case design that can be produced using those tolerances. So moving on to our workflow. So this workflow takes actually 8 steps, starting from the what dimensions that we want to calculate. So for example, here it is an example of assembly of a two components. The below one is spigot and the above one is a ring. The designer wants to calculate what will be the maximum or minimum distance between the base of this spigot and this ring face. So in step 2, what I will do is I'll just dimension my part based on some tolerance criterias individually. So you will have to individually give some dim expert dimensions to every component that you are going to analyze. After giving dimension to each component, you'll come to your assembly, and you can see over here in this tab, here is a add toll analysis study option. So you'll just click on this small icon. Then you will select your two planes or whatever you are going to measure. You can also select two cylindrical faces or some 2 points or different combination of those. After that, you will select the assembly sequence, like in what sequence you are going to assemble your part. So first I'll take the spigot, then I'll assemble the ring over the spigot. After that, you will see a assembly sequence between the measurement feature is defined, and you will click on next. In the next step, I will define my references. So for example, first I'll take a spigot, and after that I'm assembling a ring. So how do I assemble that ring? What would be my reference to assemble that ring first? So my first reference to assemble that ring to this spigot is the concentricity of this two components. So this simple hole will be my first reference, and here is a plane that is the base of this ring is sitting on the top of this spigot. So I'll choose this as my secondary reference. So after selecting these two, I can see a minimum of one constraint has been applied to each part. Set additional constraint as desired or click next. So you'll see this message in a green window. Then you can go ahead and select next. So just after that you'll click on next. You can see this result. Here is an analysis summary tab. You can see the nominal value, the min max, worst case min max values, the RSS min max values, and just below this analysis summary tab you can see the contributor list also. Okay, so here is a dimension that is contributing 78.87% in this study. So we can just double click over this dimension and change the tolerance scheme for this and recalculate our study using this this icon over here. So after seeing the visual feedback, you might need some report. So for generating report, you just click on export results and you will get a detailed Excel out of the SolidWorks window. And in the Excel you can see the minimum contributors dimensions, maximum contributors dimensions, and at the top you can see your values, your the the final values that you are going to need. So here's a nominal value, here's a minimum value. So basically whatever you see over here you will get at the top in Excel. Let's move on to our SolidWorks window to see a live demo. Here's my assembly and it contains two parts. Let me just open this part. So here you are seeing some dimensions. So these are not the dimensions that you have given it during your sketching phase. These are the dim expert dimensions. So how do you give dim expert dimensions? You will just click over here at the dim expert manager tab and you can select these basic location dimension or basic size dimension and you can just dimension these things. You can also choose from embed dimensions over the embed dimensions command manager. So and the study is set up. Let me just show you how to give some dim expert dimension on a separate part. So here is a simple cell example. I'll just click on size dimension. I'll click on this face and I'll just put this dimension over here. So for defining the tolerance scheme for this dimension, I'll just click on this dimension. Then I'll select the tolerance type. Here I'm selecting symmetric type and I'll just give a tolerance of 0.5 mm to it. All right. So here is a basic location dimension tool as well. You can define that. And you can do the similar dimensioning scheme at other features as well. Let me just take you back to my SolidWorks tolerance study. I'll just close this part. I'll open this part. And here's the dimensioning scheme for this ring assembly, the ring part as well. I'll close this one. And so before doing the analysis, let me just show you one interesting thing over here. Okay, so here I have given some tolerance scheme to this part. So if I go to the DIM expert tab, here I have a show tolerance status. So if I click over here, I can see all the yellow faces. So what the yellow faces indicate, it indicates that these faces does not have any tolerance defined for that. All right, so if the faces are green, uh, then the tolerance scheme is defined, completely defined. If it is yellow, then it is underdefined, and if it is red, then it means that face is overdefined. So it is similar to sketching dimensions. Let me just close this one, and I'll do the tolerance study on these two parts. So you might say that if I'm doing a toll analysis study, and if the tolerance scheme is not properly defined, how the tolerance study will be done. So for doing the toll analysis study, all the tolerance scheme that might affect my dimension are already green faces. Okay, so I'll just close this one, discard changes. So I'm in the assembly window, and here I'm not seeing my DIM expert tab. So in showing the DIM expert tab in your assembly window, you'll have to choose this toll analyst add-in. So you'll just click on this toll analyst add-in, and you'll be able to see this small DIM expert manager tab. So after that, I'll click on this toll analyst study. Then I'll choose these faces, and it's showing me the nominal value as of now. I'll click on next. I'll click the I'll just select the parts in sequence, how it is going to be assembled. Just click this one, after that click this one, and then click next. Here it is asking me for the reference. So when I assemble this part in SolidWorks assembly, I have given some mates. So I need to set some references with respect to those mates. So I need to prioritize which mate I'll be doing first, or which reference I'll be using first to assemble this part on the previous part. So here, if I want to assemble this ring over to this spigot, I'll uh, I'll try to make it concentric first. Okay, and then I'll just put this put the bottom face of this ring assembly or the top face of this spigot part. So only one reference is sufficient. Here it is showing a minimum of one constraint has been applied to each part. Set additional constraint as desired, or click next. So whatever dimension or whatever references that you are giving it, whatever constraint you are giving it, it is going to affect your tolerance study. So here I have given just this cylindrical faces as my primary constraint. So my tolerance study will not consider any other parameters when it is going to be analyzing this part. So I'll click on next, and here it is showing me the results, and here is the graphical view as well. You can see this is the this value is the worst case maximum, as you can see the analysis summary window. So this is the maximum value that can be achieved in this part, and here is the minimum value, and these are the RSS min and max values. Also these are the contributors list. and if I choose the minimum, it will show me the updated graphical view, and it will show me the updated contributor list. So this dimension is affecting this whole toll analysis study by 78.87%. So I'll just double click on this one, and I'll change the tolerance to 0.25, click enter, and recalculate my study, and it will update the results. So very easy to use, and within just one click it will export the complete Excel. Let me just show you the Excel. So here is your toll analyst measurements, and these are your minimum contributors, and these are your maximum contributors. So with this, I would like to conclude this session. Thanks everyone, and have a good day.